Hello. Hello, 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 hello. Ah, Let me know if y'all can hear me. Um, yeah, we have a lot to go over today. There are three sets of slides that I'm going to use. And so, that being said, let's get started. Now, um, this session today and this entire week is going to be extremely like coding heavy. So, make sure you have VS Code open and you have a fresh project. Okay? So what I mean by fresh project, I mean like the following. So should open up your VS Code. It'll probably show the I see the welcome page. Help, welcome. You probably have something like this. You know what I mean? Probably something like that. So you should go here, go to, open folder. This is how I always do it. Yeah, sure, we'll go to SoDA here, and then we'll call this node module. Okay, cool. And then you should have a fresh project. Okay, today's all about Node, but before we can talk about Node, you need to understand HTTP because that's going to be the protocol in which we're going to be using, Node.js as. So we're going to be using Node to build our out and HTTP server. So if you're from Sac State or something like that, then you probably know like, oh, wait, is my monitor resolution funky? I think it is. Let me fix that real quick. Um, let's see, identify. Oh, okay, perfect. Yeah, like I was saying, if you're from Sac State, then there's a class called CSC 138. I'm basically going to talk about the most important part of that class, and that's the HTTP part, the networking. So that's what we're going to talk about today. But first, let's talk about what the heck is Node. All right, so let's start here. So what the heck is Node? So that's the logo for Node. You've probably seen it around. Sam says, are we going to go over the HTTP protocols post? Yes, we're going to go over the entire thing, all of it. So what is Node.js? So here's some historical information or facts. It was created by a software engineer called Ryan Dahl in 2009. He's also, just as a side note, he's also created this new uh, server framework called Dino. It's not production ready, but you know, it's almost there. So, anyways, Node.js is open source, cross-platform, works on Windows, Linux, and Mac. It's basically a JavaScript runtime environment. It allows you to execute JavaScript outside of a browser. That's what Node is. Okay. And so this allows us to use JavaScript on the server, not just on the browser. And this allows us to do some asynchronous programming, like we have a single threaded and non-blocking. We'll talk more about what that means. This is all built on top of Chrome's V8 JavaScript engine. So I forget. Okay, so Firefox has something called SpiderMonkey. That's their JavaScript engine. Internet Explorer is Chakra, I believe. Edge is Chrome V8, and then obviously Chrome is, V8. So, yeah, and so what is Node really? Node is just a C++ program. That's it. That's all it is. It's just a C++ program. You feed it some JavaScript code, a file, and it basically executes in V8 with a bunch of other magic stuff, and then out comes some result. That's all it really is. Now that's a super oversimplification, and I don't mean it to be disrespectful to Node because it's a freaking amazing framework. But I'm saying like the amount of moving parts here that you have to manage with is very minimal. It's just a JavaScript. Well, that's a beautiful thing. And so these are just some of the companies that use Node.js, and this list is growing. This list I came up with just, whatever top 10. This was what, back in 2018 or 19 when I created this. There are some big players here. Okay, everybody uses it. So from what I'm hearing, um, I guess we could add to this list is like Intel, Nvidia, AMD. Uh, uh, I wouldn't doubt if Chevron was using Node.js into some capacity. I mean, if you're using React, you're using Node, you just don't know it. Okay. So, I mean, almost like it's everywhere. Okay. It's a beautiful thing. It's everywhere. So, if you want to work at any one of these companies or any kind of startup company, then you have to understand Node.js. So, here are some cloud platforms that support Node.js out of the box. We have Amazon Web Services, Heroku, OpenHat, Google Cloud, and there's a bunch of other ones. Azure, again. We will probably be focused on Amazon once we go into like deployment. We're going to focus on Amazon and probably Heroku, but probably mostly Amazon since that's more like a real life uh, thing is being able to deploy to Amazon. Uh, and Heroku is just, it's there. So this is what we need for our development environment. Node.js has to be installed. VS Code is preferred. I can only help you if you're using VS Code. If you're using something else like Atom or Notepad++, maybe I can help you. But all the extension stuff I'm going to be talking about, it's all in VS Code. And the other program you need is Postman. So Postman is going to allow us to do some HTTP requests, like put, delete, update, stuff like that. Um, that you cannot do with the browser because a browser, if you just type something into the URL, those are all GET requests. And so what we're going to be going over is the Node.js architecture. We're going to build a RESTful API using Express. I'm going to go over some database management systems like MongoDB. We're probably not going to touch on SQLite, but we will touch MySQL, as I still believe that even if you're going to learn MERN stack, you should still learn MySQL no matter what, because like no matter what company you go to, somebody's always touching SQL. I like MySQL because it's open source. Well, I don't really use MySQL anymore. I use MariaDB, but it's almost the same thing, but there's some differences. But you should still learn how to use relational databases. They're not going anywhere. Okay, MongoDB is great, but you should still focus on learning SQL. Mongo, you can learn that as well, but SQL I think takes a little bit more practice than document-based languages. Okay, and we're probably going to be deploying to AWS. Probably not Heroku, but AWS for sure. And source controls we're going to be talking about like GitHub and Bitbucket. And those are the two biggest SVNs, so we'll be using them. Okay, so there's that. Okay, so let's do a crash course in HTTP, because what you need to know for you to become like a grandmaster at this stuff. Okay. So let's talk about the protocol. So what the heck is HTTP? HTTP stands for Hypertext Transfer Protocol. It was developed by Tim Berners-Lee at CERN in 1989. You can see the RFC 7231. You can, if we click on this is actual link, it'll actually take you to the specification here. You can actually read the whole thing. Look how small this little scroll bar is. This is the entire specification for this protocol. Everything that needs to happen. Okay, so if you need to if you really need to if you want to learn more about a specific header or anything like that, or what's supposed to happen, just go in here, Control F, and then look for the information. Just read this. There's also other things, this might be a little bit dense, but it's totally there. Again, remember I told you guys gonna have to get used to reading documentation. Okay, another thing about HTTP is that it's stateless. So what we mean by stateless is that when you do a request, any subsequent requests that come after, the server has no idea who you are. Or, I mean, the protocol has no idea who you are. There is no caching system like built in. All cookies and all these things, these are just like techniques that we use in order to make things, kind of stateful. So the server knows who you are, but the protocol has no idea who you are. okay? It has no idea the previous request you've done. It treats every request as if it was a brand new request, okay? And here are some popular status codes that are, you've probably seen, like 200 or 404, even 502, bad gateway. You ever tried to, like, use a website and it was down? Um, and yeah, and here it's just about communication. So the communication is pretty basic. You do a request, for example, a client request for a web page, okay? And then a response would be like, the server giving you HTML. That's really it. There's not much to it, okay? But because we only have these two, like, or at least, request and response, you can do a lot with it, okay? It's simple, but damn, it's powerful. And again, we got to talk about, how this is stateless. So again, the request, there's no knowledge of the previous messages, okay? Any of those things that you need for your application to be quote unquote stateful or anything like that, you have to handle that yourself using things like cookies or tokens or something like that. The HTTP protocol has none of that, okay? You can do a lot with it, but it has no state information. Every request is treated like a brand new request, okay? So we can use cookies, local storage, and sessions. These are mechanisms or techniques so we can store and retrieve client information. So, when you log into, Facebook.com or something like that, you don't ever have to type in your password again. Why? Because the cookie was stored on your browser. That has nothing to do with HTTP. That's just something that was developed to accomplish things like this. The requests are still stateless. So each request response cycle is brand new transaction. TCP is closed as soon as the server responds. Okay. So again, in 138, or if you take a networking class, TCP is just one of the many transport layers. So, some transport layers is TCP. There's UDP. And there's some other ones. Okay, like maybe like WebSocket. That's another transport. Okay, each HTTP request is a brand new transaction. And again, HTTP is stateless. And again, I have to repeat myself here that HTTP is stateless. It has no state. Okay, I'm drilling that into your head because if you find a situation where you're like, hey, why doesn't this web page remember me or anything like that? It's like, bro, it's stateless. It doesn't know you. Okay, that's a good and a bad thing. Okay. So here's an anatomy of what an HTTP, request looks like. Okay, so start line, we have the request method. Okay, so we have the request method. So here we have, it's a get. You can see here there's a request method, get. The protocol, okay, we have the protocol. So the protocol is the, HTTP, whatever, HTTPS, anything kind of like that. So you have that. And then we have this thing called headers. Okay, we have headers. Okay, so these right here are the request headers. You can see this. Everything to the left of the colon is the header. Okay, the header that we're talking about. So for example, host, that's your destination. Where you trying to go, right? Remember, this is a request. We're trying to go to google.com. Accept, right here. This is the type of data we are expecting to receive. Okay, so we're saying, hey, when I go to google.com, by the way, I only know how to speak in HTML or XML or whatever, these things are, right? XHTML stuff, okay? I'm basically telling, hey, I only know how to speak this language. So if you send me JSON, I'm going to crash because I don't know what you're talking about. So we let the server know what's the response, that we're kind of looking for here, right? You can tell it the format. Okay, and then user agent is basically about you, right? The device. In this case, we're talking about the browser. Okay, so it identifies the browser, identifies the OS, though, user agent is actually kind of messed up because, here I was using, well, this one might be okay, but you'll see there's some problems. You can't really use the user agent anymore. It's been riddled. But anyways, here I was using Firefox on my Mac. So it shows right here it was Macintosh. There's the OS version and there's some other stuff, okay? That's basically it. If I was on my, you'd say on my Android device or my iPhone, this would change. Might say Android, might say iOS. And so here's a typical response. So on the start line here, we have the request method. So there's the, again, you still have the get, the protocol, we have the HTTP, and then we have this new thing, the status code, right? Status code is okay. So the server responded with, okay, everything went well. Yes, I understand what you want. The thing that you want, I also have. So everything went okay. So when you have a 200 okay, everything's good. And then here are some headers that are unique to responses, like a content type. So the server, in this case google.com, told me what the payload or the body is. So we go to content type here. It says, hey, by the way, everything inside of the body is in this text/HTML format, and the character set is in UTF-8. Beautiful. Now my browser knows how to parse this and knows how to interpret it. The content length is the size of the payload in bytes. Okay, this is in bytes, so there's the content length right here. And so the server said, hey, by the way, in this payload, there is 60,686 bytes. So divide that by 1024, and that's how many megabytes. So this page is about 6 megabytes. Okay, and then you have this set cookie. This is a server, so they know who you are. Okay. And then finally, we have the actual body. We have the actual body. And this is, what we sometimes call is the payload. In this case, it's HTML. Okay. So if you were to look at the response and click on response, here's the preview. And then if we look at the payload, it's just HTML. It's a lot of HTML, but that's all it is. It's just HTML. In this example. Okay, just in this example. Okay, so if you click here on this this link here, I'll take you to MDN right here. And it gives you some more information about HTTP if you want to read through these, through that kind of documentation. Okay. So let's talk about some of these fields here. So we have a thing called a cookie. So this is the stored HTTP cookie sent by the server using set cookie. So if I'm on the server and let's say you request facebook.com and you sent me your credentials for the very first time, your username and your password, what will happen is instead of you sending me your username and your password every time, what I can do is I can store, big air quotes here, your username and password inside of a cookie. Okay? So once I received your username and password and I have been able to validate that, yes, this account is a real account and the password is in fact correct, so I've done my validation, I can basically put together the username and password and use some kind of mechanism, doesn't matter what, but I'll store your username and password. And then as the server, I tell your browser, hey, in this set cookie, save this cookie, please. So the next time this person requests facebook.com, you can send me this cookie. I will read the cookie. I will then extract the username and the password. I can then do subsequent validations without the user having to send me their username and password all over again. The browser will automatically set cookies that the server has already set. Okay? So you don't even have to do any of this. The browser and the server will do this all together. So that's pretty cool. Again, HTTP still stateless. We're just sending more information through the protocol. Okay? Again, still requests are still stateless. Okay, and then there's another header called accept, which advertises which content types the browser can understand. Sometimes we just want XML, or sometimes we just want the JSON. Okay, sometimes we want HTML. Okay, whatever you choose. This is also what's called the MIME type. Okay, the MIME type. I forget what it stands for. It's like multi something media something encoding or something like that. I forget what that MIME stands for. It's something media encoding. And the user agent just allows the network protocol to identify the browser, operating system, the software vendor. But you should not use the user agent as a unique identifier because this is bad. Multiple people can be using Firefox on a Mac. That's not unique. So don't use this as a unique identifier. This just tells you, who's, you can use this as a way to, data mine or whatever, what kind of browsers are using your service. Okay. So you can prioritize bug fixes or whatever. All right, content type. This tells the server what type of data is being sent. So like if I, from the request standpoint was sending data to the server, I can tell it, hey, I'm going to send you HTML for whatever reason, or I send you text plain, so plain text. More likely than not, you're going to send application/JSON. You're probably going to send some JSON or XML or a file. It doesn't matter. But, you're telling the server, hey, this is the data I'm sending you. Again, if you're not sending anything, you just leave that not set. Content length. Okay, this is an octet, so 8 bits per byte. This indicates the size of the entity body in bytes to the recipient. Okay, and again, there's a lot more, but these are some of the ones that you should probably know. Okay, and then in the response, there is a special header called server. You might not always get this. Some of them will send this. This just contains information about the server. For example, if you, hit a server, let's say ubuntu.com or something like that, it'd probably say something like Apache 2.41 Unix. This is usually hidden because it prevents hackers from knowing the server type. I don't think you should use this header. Okay, I really don't. I think you should not use this header at all, but if you want to, by all means. The reason I think this is a bad idea to have this set is because if they know what your engine is, or, Apache's your file server or whatever, and they know what version, if there is an exploit for this particular engine, in this case Apache and the operating system, then the hacker, you kind of already done some of the hackers' homework for them. You gave them the answer, what kind of server you are, and then if there's any exploits, they can, easily hack your server. For example, if you're to go to google.com and then look at the response, if you look at the server, it literally just says Google, right? They don't give you that kind of information because that's not for you to know. I have used an extension to change my user agent in my case. That was just to change my OS in the string to Android so that Instagram would give me the mobile version. Oh, yeah. That's something you can totally do, yeah. I can see how this can be abused if this is used as an identifier. Yeah, nobody uses the user agent as an identifier anymore because it's not unique enough. However, there is a thing called fingerprinting, where a unique identifier can theoretically be created by using a series of different, metadata of you, and then they could create a fingerprint. So yeah, it is possible still to create a unique identifier. That's a problem, but it's fine. Okay, set cookie, again, it will be sent from the server, and it'd be like, hey browser, set this cookie, and then the value would be the actual cookie to be stored on the browser. Okay, date contains the date and time in which the message originated. So the server can tell you when it actually received it. Okay, not when you sent it, but when it received it. Okay. Content type, again, it's good. This just tells whoever requested what the body is going to look like. Usually, if you tell it, hey, when you say accept, you say, I only accept application JSON, it will respect that and send back application/JSON. It may not always, though, but, it's going to try and respect that. Again, content length is just going to indicate the size of the entire body in bytes, and that's about it. So, again, there's a lot of similarities here. Okay, now let's talk about HTTPS protocol. What is that S? So S stands for secure, and this uses something called TLS. Okay, so let's talk about this. So Hypertext Transfer Protocol secure. So the only difference is that S just means secure. So this uses a security protocol over HTTP to encrypt the messages. Okay, that's it. That's all it's doing. It's not adding anything else. It's just encrypting. Okay. Um, so you might have heard of like SSL and TLS. So SSL stands for Secured Sockets Layer. It's a cryptographic protocol and it is now deprecated. TLS stands for Transport Layer Security. Again, it's a cryptographic protocol and it's just, it's the successor to SSL. Okay. And, it just uses certificates. Okay. So look for the lock icon in your URL bar. If there is a lock, it's because the browser knows that it's using TLS to do the communication. Okay. So the handshake goes like this. The client says hello to the server, right? Before you even send like google.com, it says hello, and the server responds with, hello, and at the same time sends you a certificate and then lets you know when the server is done. Okay, done saying hello. Then the client does a client key exchange and send you a key. Okay, it's a public key, and the server, and then the client also changes the cipher spec. So it's like, hey, can we talk in, let's just say, can we talk in, RSA, right? Because maybe the client has OpenSSL, but maybe the OpenSSL that it has only supports RSA, and the server has OpenSSL as well, but only supports, maybe supports RSA, but also supports like AES or some other stuff, right? So the client will communicate to the server saying, hey, can we speak like this? And basically that's it. Like, can we use this algorithm to encrypt our messages? And then the server will usually respond with, yeah, okay, sure, yeah, we'll use AES or we'll use RSA or whatever, or SHA, whatever, to encrypt. And then eventually, once that happens, everything's fine, boom, we're done. Server change cipher spec. So the server tells it, okay, yeah, we'll talk in RSA, we'll talk in, AES, whatever. And that's it. Okay, and then we're done. Once that happens, then we can actually start communicating over that channel. Being like, okay, now can I have google.com? It's like, yeah, here's the HTML. But when it sends it, remember, it's going to send it over a channel that's encrypted. So when the client, the browser, gets the encrypted message, it's able to decrypt it, and then the browser is then actually able to interpret it. So this, you do nothing. The browser and the server are doing all of this automatically. So here's an example of looking at some of the certificates here. So this is for SSL. This was developed by Netscape in 1995. Damn, that was a long time ago. um, so there's SSL 2 and 3. This was deprecated by the Internet Engineering Task Force because there are vulnerabilities in 2 and 3. So basically, if you're a server admin, you should not have SSL at all enabled. You should destroy that part and just have TLS only. Okay. Okay, so if you go here on Google and I be like, hey, what's your certificate? Be like, okay, here's my certificate. Okay. And it says SSL, which might think, whoa, what the heck's going on here? But it's really not. It's still just using TLS. It just says it's SSL. So let's talk about TLS real quick, and I'll explain what this is. So the TLS is just, again, transport layer security. It was proposed by the Internet Engineering Task Force in 1999. It's about 5 years after SSL came out. This is based on 3.0 and is now the industry standard. I don't think TLS has been cracked yet, but we never know. Anyways, SSL has been superseded by TLS. Don't worry if you see mention of SSL in G Suite. Let's talk about Google specifically. All areas that mention SSL are now using TLS. So it's possible that there's just a bunch of strings around that say SSL, but they're not SSL anymore. It's all TLS. So, but you never know. Okay, so that's that. If hopefully somebody has any questions, let me know. Now I'm gonna keep going because we got a lot to cover. All right, so let's talk about something called CRUD, CRUD operations. And again, so what I talked about right now, hopefully you're taking notes or something like that, or paying attention. Those are valid questions to ask during an interview. Like, hey, what's the HTTP protocol? You should be able to explain what it is. Oh, it's just a communication. It's just a way to communicate between, two devices. That's really it. Usually, a client would be like, a browser or a mobile phone, something like that. And then, the 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 recipient, would be like the server would be like Google or whatever. That's really all it is. So and the server just gives you a response. So all you're doing is requesting, and then somebody's responding. It's really all it is. Okay, so CRUD. This is an interview question. So if you're looking to get a job doing this, this is very, very important. This is very super basic entry level questions. So what is CRUD? So CRUD stands for create, read, update, and delete. Okay. Well, they talk about CRUD operations in various, uh, frameworks or mechanisms. They're always talking about this. Is your thing CRUD friendly? For example, is SQL CRUD friendly? And the answer is yes, because SQL can create things using insert, it can read things using select, it can update or modify using update, and SQL can delete things or destroy by calling delete. Okay, cool. What about HTTP? Yeah, HTTP can also create things using put and post. HTTP can also read things using the GET request. HTTP can update or modify using put, post, and patch request. HTTP can also delete or destroy using the delete request. Cool. And RESTful web services just use post, get, put, and delete. How nice, you only have to worry about 4 things. Beautiful. So what the heck is CRUD? These are just abstract operational interfaces. They don't really mean much. In fact, if I say I want to create something, let's say using a RESTful service, I could create it using a GET. It doesn't matter, right? These are, well, SQL, it matters. HTTP doesn't matter. REST doesn't matter. Because at the end of the day, it's going to depend on how you develop the server and how the server respects these, what we call the HTTP verbs or methods. Okay? That's why we say they're abstract, because it all depends on the implementation, whether you actually respect what they actually, mean. So there are 4 basic persistent storage functions. So we have create, read, update, delete. That's all CRUD is. And then each letter can be mapped to, these are just some examples of some of the more popular things that you do with documents and data resources. So SQL, how you can create stuff. HTTP, how you send stuff, how you get stuff. REST, basically, what HTTP kind of, actually, no, let's not even talk like that. REST is just how you're going to architect your API, your web API. That's really it. It honestly doesn't have much more than that. Okay, it's just a way to develop your web APIs in a way. Okay, you don't even have to use HTTP. It doesn't have any mention of HTTP. You could use something else, but HTTP is usually the transport, protocol that we're going to be using. Is that. Okay, so let's talk about some of these verbs and methods. So in HTTP, when we say get, what we mean is we're trying to retrieve data. We're trying to grab some data from somewhere. Okay. Post is we're trying to store new data. Put means we're trying to replace existing data. Patch means we're trying to update existing data. So the difference between a put and a patch, think about it this way. Let's say you have a shopping cart where you can only have one thing in your shopping cart. Well, if I do a put, I'm going to replace the item that was there with something new. Okay, that's easy. Patch. Think about it like if you have a Facebook profile and all you want to do is update your name. Well, that's a patch. We're just going to update some existing data. We're not replacing your entire profile. We're just going to update this one little piece of data, which is like your name, for example. And then delete means obliterate the whole record. The whole thing's gone. And here are some status codes. So status codes is basically what we can use to reply back to a request to see if that request has succeeded or failed. So this just gives you the status in the response of the request. So, the ones we usually talk about is like 200s. So if you did a request like, can I have google.com's homepage? And if Google's able to understand what you're talking about, then it'll be like 200. Okay, cool. General success. Everything's good. If you go on Facebook and like it's your first time there and you create an account, as soon as you create the account, it's probably going to send a 201 created. A new resource was created. Or if you upload a file, you might get a 201, or something like that. Or when you submit a post, you might get a 201. Yay, your post was created successfully. Cool. 204, either updating or deleting a resource. So when we go to delete stuff using, when we build our API, we want to delete something, we can reply back with a 204. We were able to successfully delete the resource. Okay. You can also use this when no response in the body is going to be returned, so the body is just blank. You could use that. 300s are for like redirection. So if somebody says, hey, can I look at google.com? But then like, for some reason they want to switch from google.com to like google.net, but you requested google.com, they might do a redirect. So, hey, you requested google.com, but now it's google.net, so here's google.net, and you'll get a 300 in that response. And then the client errors, the ones we're probably familiar with: 404, not found; 43, forbidden, trying to access a resource that you don't have the proper credentials for, stuff like that. Okay, and then unauthorized, 401, you gave the bad, username, password. That's about it. Okay, now let's talk about HTTP 2.0. I think, all right, so let's talk about this right now since we're in 2021. Google, if I remember correctly, yes, it was Google. No, was it Google? Yes, it has to have been Google. It was Google, Microsoft, and Facebook. They have developed something called FAST. Ah, dang it. What was it called? I think it's called FastNet or something like that. I forget what it's called. But anyways, it might replace HTTP altogether, okay? Because HTTP 2 was supposed to be a response to what was lacking in HTTP 1. Okay? So, just as a historical record, we're probably phasing out HTTP 2, and we might move over to this new protocol called dang, oh, let me look it up. It's called fast something. Fast HTTP. Fast something. New protocol. Speedy. That's what it is. Speedy. Oh, quick. No, it's quick. I'm sorry, it's quick. This is the new protocol. Okay, just so you guys know, because these slides don't talk about it, but this is the new protocol. Quick, this is going to, so in the future, instead of HTTPS, you might end up just saying quick. I think Chrome already supports quick as one of its protocols. It's still in the experimental stage, but this is going to be the new protocol for a lot of this stuff in the future. So yeah, it's a general purpose transport layer network protocol. This was designed by Jim Ruskin at Google, so this is a Google thing. Microsoft threw in some support, yeah, so for stuff like that. I think Facebook also did support for this as well. But yeah, we'll see what happens here. I just wanted to let you guys know about this. Anyways, let's go back to this. So what is the difference between what we know HTTP 1.1 and HTTP 2? What the heck is the difference? It's how requests are done. Okay, so let's look at how a request is normally done. So this is step one. We open up a connection using, let's say, TLS, for example, okay? Or something. So the TCP thing is finally connected, whatever, we're done. We're connected. Okay. Then we can finally send the GET request for index.html. Okay, cool. We ask the server, hey server, can I have index.html? You know, let's say from Google or something. Server's like, okay, cool. We respond back with index.html. Nice. Now the browser has the HTML. Now that the browser has the HTML, it's going to start parsing things out. Now, remember when we talked about CSS and JavaScript, how you use in the header, how you link them, right? There's those link tags, say source, and then like where those files are. Okay, well, when you send the HTML, those files don't come with it. All you sent was the HTML. The browser then starts to parse the HTML, and it looks, oh, hey, you want the CSS file? I don't have it. So I need to ask the server now, hey, can I have the CSS? So you can see how slow this is. So the bigger your head is in your HTML with all those files, those are all individual requests that have to be fulfilled one at a time. So let's say in your head you have link styles, rel style sheet. You have that in your head. Well, once the browser interprets this, is like, well, I need styles.css. Hey, server, can I have it? So you send a GET request. Yo, can I have it? Then the server's like, yeah, sure, here you go. Then the browser continues parsing out the HTML, and it finds, hey, we need the scripts.js file too. So then the browser's like, hey, server, can I get the scripts, please? And the server's like, yeah, sure, here you go. Boom. Now that it has the CSS, the JavaScript that has HTML, now we can actually render it to the page. Now we have everything to render. And then the connection gets closed and it's done. Okay. What's the problem there? Right? We have to do things one at a time, right? One at a time. What HTTP proposed, what it was trying to do, was something called multiplexing. That is, we can send multiple gets at the same time, and then we can wait for all those responses to come back instead of doing it one at a time. So for example, here is the new setup for HTTP2, what it was supposed to do. We establish a connection. Great. The browser's like, okay, now that we can communicate over TLS or whatever the heck, can I have index.html, please? And the server says, yeah, sure, here's HTML. Index.html, cool. Then the browser starts parsing out the HTML. Then it's like, oh, hey, look, here's some styles. But instead of sending the request, it's going to send it in batches. It's going to wait for some other stuff that it's probably going to ask. So instead of just asking, for one thing at a time, it's going to put things together kind of like in a shopping cart and be like, server, can I have all of this? Basically. So as it's going through, it's like, oh, I notice I need styles, and I also need Java scripts.js. Cool. Once it finds everything it needs, it then sends to the server, hey, can I have these files? And the server's like, okay, here are all these files. And then boom, that's it. And then now the browser has the HTML, has a CSS, and it has a JavaScript, but it didn't have to do so many requests. Now we're done. Okay. You can think of this as the same optimization as if, let's say you were trying to move. Let's say you were moving. You had a U-Haul truck, and then you were trying to move items from your garage. How ridiculous would it be if you only grabbed one item at a time? So instead of getting a box and putting everything inside of that box until the box was full, and then you put inside of the U-Haul, so you only took one trip, you took piece by piece. So let's say you had a lamp with a light bulb in the shade. Instead of taking the whole thing, you took it apart and you put the lamp, then you walked back, you got the light bulb, you went back to your truck, dropped it off, then you went back, got the light lamp cover, picked that up, then you went back to your truck and dropped it off. How dumb is that? Well, that's what HTTP, or I shouldn't say HTTP, but well, yes, well, that's what the browsers have been doing for like the longest time. And that HTTP2 was basically trying to create a box where you can put a bunch of requests there at the same time and then send that off. That was the point. It didn't turn out that way. There's still some problems with HTTP2. And that's what Quick is for. So just letting you know that HTTP2 exists. And you're probably already using it. You probably don't even know. Okay. And so yeah, some of the benefit, probably finish this up. Some of the benefits is that, again, the multiplexing allows us to join data together in one go. So for example, requesting the CSS, alongside JavaScript or whatever. It's supposed to be faster and it's supposed to be more secure. That was the idea. Okay, that's HTTP2. Okay, but Quick is now around, and I don't have any slides for Quick, but just know Quick is going to be the future. All right. Cool. So now that all the slides are done with, let's do some Node. Okay. In a lot of ways, you've already been doing Node. You just didn't know yet, right? Because of the way I've been structuring this. We've been running our JavaScript using Node. That's the engine that executes our JavaScript. That's what we've been using. But we haven't done anything Node specific. Well, that's going to change now. So first, let's talk about how can we get stuff, right? Because in Node, there's going to be a lot of utilities, right? We call these modules that are already built into Node.js that we would like to use. Okay? So how do we get it? Well, if you come from like a Java background, then you know how to bring in those dependencies, right? You say import, java.util. Whatever, right? And then that brings in those classes, that namespace, that package, we usually call it in Java. In C#, it's the same thing, right? You say import, or actually you say using system.net. Now you have access to all the classes under the namespace of, system.net or whatever, for example. In C++, you use the inclusion guards, pound include, whatever thing you're trying to bring in, whether, file or whatever that has a bunch of functions or classes or whatever it is you're trying to do. In Node, we use the require. That's what we do. Okay, so here's an example. I'm going to show you some examples of these modules that we can use. So again, it's similar to Java's import keyword, similar to C#'s using keyword, similar to C++ pound include inclusion guard. This follows the common JS module system, which as of, I believe, Node 14, okay, you can see how old this is. This is Node 10. As of Node 14, you can now use ES6 imports, which is what we were using with React, which was import blah from. Okay, I still think you should use require for now, and then, slowly migrate over to import. Though I think they should work all the same, but, you just never know. Okay, this pulls modules from files specified by the module name. Okay, and here's some of the built-in modules. So this is from version 10. There's no easy way for me to change this. I believe I have version 14 installed now, finally updated, so I should be able to just do that. There we go. This is version 14. So these are the types of modules that we have access to. Okay, these are just some. So for example, we're going to be working with HTTP. So we click on this. Okay, we have the table of contents here. Okay, and this is our thing. It's like cool. So now these are everything that comes inside of the HTTP module. So it says right here, to use the HTTP server and client, one must require HTTP. It even tells you how to do it. Cool, not bad. All right, so let's do some coding. Finally, you guys don't have to hear me talk anymore. All right. So, do I say how to do this? Don't remember. Let's see here. Yes, okay, so I say okay, so we're going to use the HTTP module. Again, this is built into Node, so we don't have to build this ourselves. And this is going to send and receive data over HTTP protocol, okay? And this is going to allow us to create a server on a specified port and allows us to respond. So again, let's do this. So here's a little demo So we're going to create a file called app.js, and then we're going to import the HTTP module from Node. So again, just in case you need to see it, this is the code. But again, I'm going to do it along with you. Hopefully you guys are following along. So we're going to create a file, app.js. Beautiful. Now we're going to bring in that module. So we say const HTTP. Let me blow this up a little bit. You guys can see. Const HTTP is equal to require, require, and as a string we put HTTP. Not HTTPS, but HTTP. There we go. We hover over HTTP, okay, and it's using this ES6 syntax, but we have it now. Cool. That's it. So create a file called app.js and import the HTTP module from Node. Beautiful. So this is what the code looks like so far. That's it. One line of code. Again, this is just JavaScript, right? So you just put a comment here. Brings in the HTTP module from Node.js. Capitalize the N. There we go. That's it. One line. Done. Okay. Next. Let's talk about the server class. Okay, so server class. So this allows us to listen on a specified port and host. Okay. So we're gonna use this to use a requested response object for HTTP messages. Again, what's the protocol like? Well, you have a request and then you have a response. Well, when we create our server, we're going to have a request object and a response object. That's it. It's very simple. Okay. Okay, and this must be created by the HTTP module. So you're going to just say http.createServer, and then that's it. We then give it what's called a handler, a function that will handle the request and response whenever they come in. Okay. And then we call listen on the specified port. So we need to specify a port. Okay, this is wrong. This should be a double line right here. There should be a double line. But yeah, we figure out a port we want to listen on. Okay, it can be any port. Well, not really any port. Some ports are reserved, but pick any port above 3000. Let's just say, and you're good to go. So once we create the server using the module http.createServer, pass it a handler that accepts a request and a response. That's it. We then say, okay, now that we have the server, we're going to say server.listen on this port. We give it a callback that will get executed if and only if the server was able to listen on that port and is running. And then we're just going to log to the console, listening on port, whatever port. And that's it. That's it. Very simple. So pick a port, any port. I'm just going to use 3000. We need to create our server by using http.createServer. Give it a handler that can accept a request and a response. So this is just an anonymous function. We've already used this before. These are called arrow functions. Then this will return a server object. And on the server, we can then call listen. This is a method. We pass it the port and then a callback for when the server actually starts listening. That's it. Let's do it. So pick a port, any port. I'm going to pick 3000 for now. Okay, so now that I have my port, now I got to create my server object. So const server is equal to http.createServer. Boom. Now it wants to know, okay, what port, or I'm sorry, not the port. Now we just need to give it a callback that can handle a request. Notice that here it has a request. So we pass it a request. We need a response. Cool. That's it. So if you hover over this request is called the incoming message from HTTP. If you hover over the response, this is the HTTP server response. This is how we're going to respond to the requests. The request is going to give us information about what the request is, and the response is an object that we can use in order to respond to those requests. That's all a server is. Receives requests and then responds to them. That's it. Now that we have our server object, we then say server dot listen. Okay, it's going to allow us to listen on what port do you want to listen to? Well, there's my port that I created. So here's my port variable, listen there. And then here's the callback. I want you to let me know when the server is up and running. So we say console.log. I'm going to use the backticks. These are called string literals, so I can inject JavaScript using the $. Listening on port. Okay, then using injection, because I'm using the backticks, $, curly braces, turns blue. I type in my port, and then with a semicolon, done. Let's run this. Node app.js, hit run. Listening on port 3000. We created a server. Yay, round of applause, everybody. Created a server. That's it. That's a server. Doesn't do anything, but hey, it's running. All right. So now you'll notice that it doesn't return. It's running. It's literally running. It will run forever. As long as this computer doesn't die, it'll keep running. Okay. So to kill it, click over here inside your terminal and do Control-C to kill the process. Okay, done. Now it's dead. Let's go back to the slides. Cool, and so here is the code that you must write. Okay, again, there's a mistake here. There should be a double pipe, not a single pipe. I'll show you an example of how to use process environment variables. But for now, just ignore it. Just put 3000 or 5000, whatever number you want. Again, there are certain ports that are reserved, so, but just saying, I think you should just use 3000 for now. Okay, so make that 3000, and then you can say http.createServer, pass it a arrow function that takes in a request and a response. It has an empty body because we're not doing anything yet. Then once you have the server object, you're just going to say server.listen, whatever port you want to listen on, and then you give it a callback function. Okay, that will be executed if and only if the server starts to run. So if there are no problems running it, it will say this. It will say listening on port whatever. So only do that once the server is running. Okay, so let's talk about this one step at a time here. So number one, so these are line codes. 1, 3, 5, 7 are line codes. So line 1 imports the HTTP module. Use const to prevent accidental reassignment. So whenever you're using something that you don't want to accidentally reassign, use const. That's what it's there for. So when I say const HTTP, it's not possible for me to reassign HTTP. So I can't say HTTP equals undefined or equals the number 5. Okay, it's going to, crash and be like, no, you can't do that. Okay, cool. Line 3, we're specifying the port. We'll talk more about processes for now, but just know that this is wrong. There should be a double bar, not a single bar. Okay. And on line 5, we're going to cache the server object. So after we create it, we're going to store it inside of this variable called server. And then we're going to use a lambda function for the request and response object. Again, this is a lambda function, also known as an arrow function. Okay, also known as a delegate. So there you go. And then on line 7, we just say, hey, server, can you listen on this port? And then that's it. Listen on the port, and then there's your callback. And that's it. That's really it. It's pretty basic. Okay. Cool. So let's talk about localhost. In networking, localhost refers to this computer. This one. Okay. When I say home or localhost, we mean this computer. So the IP address is always going to be 127.0.0.1. That just means home or localhost. So localhost is always going to resolve to your local machine. Cool. Node.js broadcasts on localhost. So whenever you create a server, in the context of your machine, if you want to have access to it, the IP address is just going to be 127.0.0.1, or you can use the domain localhost. That's it. That's all that means. Cool. Now that we have this, let's run your node code, open up your web browser, and go to http :// whatever the port that you specify. All right, so let's do that. So here I am, going to run node app.js. It says listening on port 3000. Beautiful. So I'm going to go over here, say http / localhost 3000. Hit enter. All right, what are you guys noticing? What do you guys notice about this? What's happening? Okay. So let's go back to the slides here. So here is basically, what do you observe? Why? A whole lot of nothing. Well, yeah, a whole lot of nothing. There's also something going on. Look at that. It's thinking. It's thinking right now. Okay, it's thinking. It's not thinking. It's waiting. Alex has the perfect icon for that. Yeah, it's just loading. The little spinner. Well, why is this happening? Well, again, we need to talk about the client-server model. How does HTTP actually work? What's the architecture underneath? What's the pattern here? So again, clients and servers exchange messages in a request-response message pattern. The requester sends a request message to a replier system, which receives and processes the request, ultimately returning a message in response. Okay? The reply, you can sometimes say. A server may receive many requests from distinct clients in a short period of time. The client and server agree beforehand on how data is and should be processed, the APIs. The server tells you, hey, if you hit this endpoint, I'm going to give you this. The client needs to know that. Okay, this is what these APIs, when people talk about what's an API, it's like, well, that's what it is. It's just what we call an application programming interface. It's how you interface, with this particular application. So an example of a server is, we have, you can go here. This is Instagram's. You can go look at their endpoints. And an example of a client would be like an app. And then, the client and server agree on how the data will be exchanged. You have OAuth, RESTful API, JSON, tokens, whatever. Okay, so what we need to do is we need to actually respond. All right, so we're going to do a classic hello world, and then we're going to do an actual response. So again, we're going to send a classic hello world message to the client. Now notice that the only code that we have added here is on the response object. We're going to say .write hello world. That's it. Okay. So before running this, think about how HTTP communicates. Okay. What do you think should happen? So what do you guys think should happen with this new line of code? Response.write. So let me know what you guys think will happen while I write that. So I'm going to kill the server here. So click over here, Control C. Now it's dead. Now we modify the code. Response. This is the response object. Dot write. Okay. I'm going to send it hello world. Save. What do you guys think is going to happen? Nobody? Nobody has a thought? Okay. Well, let's try this. Okay. Again, stop the previous server using Control C, rerun it, use the res, which is the respond object, and write out hello world to the connected client. What do you think will happen? So again, the only thing we're adding is this new line right here. Res, which is the response, dot write hello world. Victoria says, we hopefully get that response. Well, yeah, that's our hopes. Let's run it. Listening on port 3000. Let's go over here on localhost. We're stuck again. Dang it. Did it crash? No, it didn't crash. I did write. Well, nothing's happening. Damn it. What's going on here? Now let's see what's happening. Okay, well, let's look at what a typical HTTP session looks like. Okay, so a typical HTTP TCP session consists of 3 phases. Phase 1, the client establishes a TCP connection. Okay, or the appropriate connection of the transport layer is not TCP, like UDP or something. Doesn't matter. Number 2, the client sends its request and waits for the answer. So the client, in this case, is my browser. Look, my client, my poor client, is still waiting. Okay. Number 3, the server processes the request, sending back its answer, providing a status code and appropriate data. Okay, that's the typical, situation. That's typically what happens there. Okay. So here we have a server. So again, we're talking about the server. The write function appends data, like a string, to a buffer. However, we wrote it, but we never actually sent it. So we need to call end. Okay, so when we invoke it, it flushes the buffer and closes the connection. So only until we say end, everything that we wrote to the buffer will then get flushed to the client or whoever requested it. So now we just need to add this extra line, response.end. All right, let's do it. So let's kill a server. Let's go over here, respond.end. That's it. So we write, and then we end. Okay, let's clear this. Let's run this again. All right. Let's go back to our poor little client. It's probably still waiting. Here we go. Localhost 3000. Enter. Boom. Now it says, hello world. We got it. Ladies and gentlemen, we got it. All right. Let's do it. Yeah, that's it. Cool. We now have a way to have our server receive requests using Node.js, and now we can reply to those requests. And that's it. That's all it is. Very simple. I see 3D is excited. Yeah, thank you for the energy. Somebody's excited. Let's go. All right, so let's move on here. All right. So again, invoke end on the response object and then revisit, which is basically what we already did. And there we go. Then we'll get hello world. That should be the appropriate response there, which is what we said. Hello world. Beautiful. Beautiful. Okay. Now as a demo here, let's log to the console all the HTTP methods and the HTTP status codes. So let's do that so we can see what HTTP actually supports. Okay, so I'm going to kill this here. I'm going to kill that. And then all I want to do is say console.log http.methods. Now you'll notice that the methods is a string array. So we're just going to do that. We run this. Look at that. So these are the HTTP methods that our HTTP module supports. ACL, connect, there's a get request, lock, patch, put. We have, let's see some of the other ones that we use a lot. Delete, post. Cool. Right there. Post is right there. Not notified. Post. All right. Let's kill a server. And now let's what's the next thing we want to do? Oh, status codes. So if you need to have access to the status codes, here they are. Now, status codes, if you see here, is an object with key value pairs, the error codes string, error code number, and the string. Okay, so let's see what this looks like. Clear this, run that. Look at that. Here are our status codes. So here we have, if we have a status code of 200, we say okay. If we have a 400, we say bad request. Cool. So what can you do with this? Well, instead of hard coding, all these responses like that, whenever we need to send something back, we can always say status codes dot, and then we, well, probably not like that. We'll have to go like this. Inside of a string, and we say something like, 200, and then we'll get the string back, which would be like, if we do a 200, we should get okay. Okay, so let's just keep that in mind. All right. Close this, delete that. All right, let's move on. All right, let's use Postman. Jim Bob says, so is a response set in the form of HTML, or is the browser turning it into HTML to show? That's a very good question. I mean the hello response. Yeah, it's a very good question. Well, let's see what that looks like, Jim. Let's right click, go to inspect. Let's go to network. Okay. And let's do this again. Hit refresh. Okay. This is our request. Oh. And it died because I'm not running this. Let's run this. Okay. Go back. Clear all this up. Refresh. Okay. This was the original request, this local host. Let's just click on this. Let's inspect this. So it was a GET request. We got a 200. Okay. Let's look at the request. Okay. This is what the browser is going to do by default. I didn't set any of these. This is what the browser is setting, not me. Okay, understand that. I didn't set this. The browser did. It said, all these things, except. I accept any of these things. Okay, this is all the things that the browser knows how to interpret. HTML, application, blah, 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 blah. It says give me anything, because this is a super generic GET request. That's what browsers do. Okay. Let's look at the response. The response was here. The keep alive, the date, or the connection, keep alive, transfer encoding is chunked, and just the date. That was it. Okay, so let's look at the response here. The response was just hello world. This is what's inside the body. Okay, there's a preview, whatever. So by default, the browser is just, if we look at under elements, the browser is just going to interpret this as here, this pre-style. It's just going to interpret it as regular text, just text. But the browser only knows how to render HTML. So it wraps whatever it is that came back in this pre-tag. That's it. That's all that happened. That's why we see it like this and not some other thing. Okay. It's a very good question. That's precisely why the next part is talking about using Postman. We want to see, what does this look like in Postman? Okay. So let's look at Postman to see what the differences are using a browser versus something like Postman. Okay, so this is the Postman view. This is what it looks like. Hopefully you guys already have it installed. Okay, so here's like a quick little crash course on how to use Postman. So there should be like this little button right here. You hit the plus icon to create a new request. You click on that, it creates a new request thing. And then you can hit, type in the request. So this allows you to change the methods. So we're going to do a GET request. And then here is the request, what we want. So we want to request localhost 3000. Then you click the button send. And then on the bottom part, the body part here, we can observe, in this section, the response back. Okay. All right. So with that in mind, this is still running. I'm going to open up Postman. Okay. Okay, here we have Postman. What is this? Oh, perfect. We'll use this. It's already set up. Cool. So kill this. So again, you can click on this little plus. It says untitled request. You can save these. That's pretty cool. Here are the methods that we can use. So we can use get, do a post, put, patch, delete. So this is the way you can test your APIs when you're building them. The way you can test. Or it's a way for you to play around with somebody else's API and you can test different headers and blah, 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 and check the responses in this little environment. That way you don't have to actually write a program. You can just use this program that's already built. Okay, so I'm type in HTTP localhost 3000, just like that. Okay. And if we look at the headers here, these are the headers that are there by default. Notice that the user agent is different. Now it says Postman runtime. Before it said something like, if you're on, on Firefox, it'll say like Mozilla, whatever. Now it's just saying the user agent, the browser, the device that this request is being done on is Postman, which is correct. I'm using Postman. But I can change this to whatever I want, really. I can, copy this, but I can change it to like, whatever I want. Okay. All right. You can also remove this. Don't have that. You can. This right now accepts, basically saying it accepts anything. You just accept anything. All right, cool. That out of the way, let's hit send. Okay, we got hello world. Now in the body, we should probably observe some things here. Okay, this thing right here. Okay, so first we see that we got hello world. Yes. Now if we go to the headers, do you see a content type? No. We do not see a content type. So what's the default then? If you don't set a content type, well, it seems to be text. That's the default type. So you can see here that Postman is saying, hey, I interpreted this as text because you didn't specify. The server did not specify what the content type was. So I'm just going to think it's just plain old text. Cool. And on the right side here, we have the status codes. So you click on this, hover over, click on it. It gives you a 200 OK. So it even tells you what 200 even means. It tells you how long it took and what's the size in bytes. Okay. Beautiful. Beautiful. So here's a preview. What you'll probably see in a browser, which is exactly what we saw when I opened this up in Edge. Here's raw, visualize. Oh, I don't have that set up, so yeah, it doesn't matter. Cool. That's it. That's what Postman. Okay. So we kind of already did this. We viewed the header. We saw the differences. Okay. All right. Okay. And I think that was it for this module. Yes, that was it for this module. Let's okay. So that's it for that module. And let's keep going. This is the logo for SoDA, old school. All right. So now let's talk about routing. How can we route different things in our request? So let's take a look at this. So let's look at something called API endpoint. So how much time do we have? 7:22. I have 8 minutes. Okay, so let's skip this for now. We'll finish this on Wednesday. Does anybody have any questions? Does anybody have any questions? Because I know this was a lot. We talked about, the what Node is. We talked about the HTTP protocols. So we have HTTP, HTTPS, the difference between them. The S means secure. You have SSL, secured sockets layer. You have TLS, uh, transport transport layer secure. Okay, and then I mentioned quick, though we didn't talk about that, but I did mention it. And then we learned how we can create a server using the HTTP module from Node. Okay, we have that. We were actually able to build one and run it. We were able to respond to a request by just printing back hello world. We ran it in the browser, and then we ran it in Postman. That's actually pretty good for one session. So my question now to you guys is, do you guys have any questions? Better summary of 138 than my 138 class with Wang. Thank you. Yeah, so in 138, you do talk about this. There's still a lot we didn't talk about. That's for like, more academic purposes, like what's it called? Packet splitting. You know how you split a packet up into chunks. So 3Ds ask, why do we need to use Postman again? It's just to get more info on it. That's a great question. That's a great question. Why do we need Postman when we have a web browser? Very good. The reason for that is because when you have a web browser and you type in something into the URL bar, like what is it? Localhost 3000. I cannot change how I get the request. This is always going to be a GET request. I have no choice. It's always going to be a GET request. I can't change that. The other thing is that look at the request. Look at all these headers that the browser sets by default. And then look at the requests, the headers that Postman sets by default. Okay? Look at the difference between them. Look at all the ones that the browser does by default and look at the ones that Postman does. Is one better than the other? No. The difference is that the browser's doing all of this by default. But what if I want to test something? Like, what if I want to see what happens if I add a header that says this instead of this other thing? This is a nice way for you to be to test those different scenarios. The other thing, which is the most important thing, is on the browser, by default, in the URL bar, it only does GET request. Okay, but what if I wanted to test out a delete? I wanted to delete something. Okay, so delete, let's say user by ID 10. I want to delete this. I click send. Right now it's just going to say hello world, but the idea here is with Postman, I could do that simply. Oh, cool, I can just delete somebody. Or what if I wanted to create something? So I can go to post. So I switch it to post. Where's post? Boom, post. Okay, I want to create under my users, I want to create something. So in the body, I can go to raw, and I can switch this to JSON, and I can send it some data. Like, I want to create the user with the name Kevin. We'll go Bob with the L name, so last name of Dylan. So we have Bob Dylan. Okay, I want to create this user. I can't do that with the web browser. There's nowhere for me to do that. I can only do a GET request, and on top of that, I can't even send something. I need some HTML here to actually do some of this stuff for me. Okay, but I have Postman here, which it's really nice. It's a great tool for developers to just test out, URL endpoints. Okay. So here I have this, here I'm just doing raw, I'm doing JSON. I'm just going to send some JSON so I can send that. Obviously, my server doesn't know what to do with this, so it always keeps responding with hello world. But I can also send it XML. So if you want to do something with XML, you can do something with XML. Like, let's say I want to create a new user. There's my user with F name, Bob. and then L name billion. Okay, there's some basic XML. Hit send. Again, my server has no idea what to do with any of this. It just keeps responding with hello world, right? So with Postman, I can do stuff like this. Heck, I can even send a file if I wanted to. I can send a file. I can go here to like this here. I can add a key. And here I'll, was it in the form data? Form data? Yes. Params. Yeah, so here I can say something like, let's say I wanted to send like a file. There's the key called file. Okay. I can go over here and I can be like, yeah, it's going to be a file. So I'm going to send it as a key, something called file. And then here I can select the file. So here I can go whatever. I can select the file. Be like, okay, yeah, send it, you know, whatever. There's Corbin Kitty, so I want to send that. Open. Boom. Then I can hit send. But again, my server has no idea what to do with that because all it does is respond with hello world. Doesn't do anything yet. But look at that. I can even send files. I can test. How does uploading a file look like? Like, does it crash if the file's too small? Does it crash if it's too big? You can test these things out. You know, you can kind of do that with the web browser, but all you can do is test GET requests. But with Postman, you can do all kinds. Okay. All right. So with that, I will leave that there. You will see the power of it once we actually start building some of these routes. Okay. So here's an example of some. Do we start doing some routes? Yes, I think we do start doing some routes. We start doing some basic routes. Yeah, here's an example of a route that we're going to build. It's quite long. So, yeah. Okay. Well, we'll pick this up on Wednesday. So hopefully, so click here and kill this, Control C. And yeah, hopefully that entices you, gets you excited. I now understand. Thank you so much. Yep. So that's what Postman is good for. Okay. Just testing out your endpoints. Again, it doesn't have to be just yours that you're building. Like, let's say you're a developer for some app, and then the client says, "Hey, we would like to use the Twitter API in our app so they can sign in." Okay. Well, you might want to play around with the API. How do you do that? Well, use Postman, read the documentation on the website, and then try different endpoints with the API key and see how things work, right? We could also do this with Open Weather Map, right? We have the endpoints, we have our API key, hit send, look what the data looks like. This way, you don't have to be constantly doing console.log. You can just try it out in Postman, see what it looks like, and how to handle the various, responses like errors and stuff. So when you write your front end code, like something with React, you know how to handle that kind of stuff. Yep. So again, Postman is just a tool. Just a tool. Okay. So if there are no more questions, I will leave it at that. And I will see you guys all on Wednesday. Hopefully you guys enjoyed learning a little bit of the backend stuff. The backend is very, very powerful. Okay, guys. So please pay attention to it. Study it. And yeah, if you guys have any questions or if you guys have any problems running any of the code that you saw today, let me know and hit me up on Discord. All right. Bye, everyone.